Okay, we're going to be looking at some application problems, but before we even look at that, we're going to take a look at a theorem, and it's a really important theorem. And that is, what happens when you take the integral of a constant function? Well, surely you've probably discussed antiderivatives of a constant function, and we've taken a look at things before in my class, I know. So if we were to take like the antiderivative of 2, for example, we might say it's 2x. If we take the antiderivative of negative 5, we might say it's negative 5x. So basically what you're doing is you're tacking on the x. But what we're doing here when we look at this theorem is we're building up to something greater, and that is something called the fundamental theorem of calculus. And so we're not going to get there just yet. We'll save that for another video for another time. But let's take a look at the theorem. It says if f of x equals c, where c is some constant, on the interval, on the closed interval, from a to b, then we say that the integral of f of x from a to b is equal to the integral of c dx, okay, from a to b, which just comes out to be c times the difference between b and a. So c times b minus a, in other words. So we're going to use this concept right here. Let me go ahead and highlight it for you. We're going to use this concept right here, all right? And we're going to apply it to the following application problems. So let's go ahead and take a look. Number 3 here says, express the following as a definite integral and then evaluate. And it says you have a snail and it travels at 0.6 feet per minute for 3 minutes. How far does it travel? Well, it's traveling at a constant pace. So what we're going to do is we're going to set this up first as an integral. And that is to say that 0.6 is the unit that we're looking at, that we want to integrate. And we're going to say that we're analyzing this in terms of a rate of change of time, so dt. Now, if it's for 3 minutes, it starts then at 0 and it ends at 3. And so, following this principle that we just set up in the theorem that I mentioned a little while ago, we're going to say, well, then it's just going to be 0.6 times 3 minus 0, okay? And so when we integrate that, when we take the definite integral, we end up with something like this, 1.8. In this case, the unit is feet, okay? 1.8 feet, all right? Because this is a constant function that we are integrating. All right, we're taking the definite integral of a constant function, and based on the theorem up here, the integral of a constant, that's what we're applying in order to figure this out. Okay, so again, we're building up to something greater, the fundamental theorem of calculus, and eventually the b minus a stuff will make sense. But that's another video again for another time. So let's go ahead and take a look at one more application here. All right. The next one says, find the output of a pump that produces 23 gallons per minute during the first 3 hours of its operation. Okay, this one is rather interesting because we're given a little bit of information here. And let's see, we know that it's a constant. We know that it's 23 gallons per minute. So we're going to integrate it with respect to time. Now, the limits of integration are what we should be concerned about, because look at what this says. 23 gallons per minute, and they want us to evaluate this over the first 3 hours. So this is going to be from 0, but not 0 to 3 in this case. We've got to convert 3 hours to minutes. So 3 hours, and each hour is 60 minutes. So we figure out that this is actually, we're integrating over the first 180 minutes. Okay, so 0 to 180. All right, let me clean that up just a little bit. 180. There we go, much better. So again, we follow the same concept from the theorem back up here, and that is to say c times b minus a. In this case, our c value is 23, and we're going to multiply that by 180 minus 0. And so when we do that, we get 4,180 140, all right? And in this case, it is gallons, okay? It is gallons. And that is the unit that we are looking for, 4,140 gallons. And so this right here is what we are concerned with, okay? So I hope that these simple applications of the theorem of a constant, okay, I'm sorry, the integral of a constant, the theorem about the integral of a constant are clear, they're understandable, the video was helpful, and as always, remember, like and subscribe.